Yesterday in 6.1, we ended with converting angles from degrees to radians and converting them from radians to degrees. Today, we're going to talk about coterminal angles. That's what we're talking about today. The prefix co means same. So coterminal angles share the same terminal side. Okay, so in order to find coterminal angles, if it's in degrees, so if the angle is in degrees, you're going to add and subtract 360. But if the angle is in radians, we're going to add and subtract 2 pi. Okay, so I'll give you a second to get that copy down and then we'll talk about it. So we all know that there are 360 degrees in one circle, in one revolution. However, you can do more than one revolution. Think about it this way. If you were to go outside and walk around the Pike football track or the track field, you can keep walking and do more than one lap, okay? If you go around one time, that's 360 degrees. But if you go around again, that's 720 degrees. So what I'm trying to say is that angles are not limited to be only between negative 360 and positive 360. You can have an angle that is 3,000 degrees. That just means that you did a lot of laps before you stopped. Okay? So I'm going to just draw a little example here. If this is my terminal side, okay, this is my original angle. If I were to wrap around more than once and stop here, that is still, even though this angle went around more than one time, it stopped at the same place, which is why they're coterminal angles. All right, so this is representing if I go around more than one time, I do a full lap, and then I keep walking, then I'll be here. Also, you can rotate the other direction. If I rotate and I go this way, that's also the same angle. So every color represents a different angle with the same terminal side. So this is my original angle. This different angle, but stops at the same place. This different angle stops at the same place. So in order to find coterminal angles, we are going to, if it's in degrees, add and subtract 360. But if it's in radians, add and subtract 2 pi. All right, so I'm going to give you a second to copy this down. This is our last example. Go ahead and only copy down, well, I don't know. You can go ahead and copy them all down. I'm just not sure how much space it's going to take, so. All right, so let's get started. 50 degrees. Now, fifth period scared me. I'm going to ask sixth period. What quadrant is 50 degrees going to be in? I'll give you a second to think about it. Don't show me yet. Think about it. Is it quadrants 1, 2, 3, 4? All right, show me. Where we at? We're in 1. You all are making me nervous, like for real. Y'all scaring me. For real, y'all seriously are scaring me. Are y'all doing that on purpose? Y'all capping? Y'all know it, but you don't want me to know you know it? Okay, that's fair. All right, so 50 degrees is right here because this is 0 and this is 90. And do we agree that 90 is less than 50? Do we agree with that? Okay, so this is my starting angle. But what if I start at 0, I do a full lap, and then I stop here? So in order to find the measure of that red angle, we're going to take 360 plus 50. My third grade teacher told me that when you're adding numbers, it's best to put them in order from biggest to smallest. So you could put 50 on top, but Miss Kagi taught me put the bigger number on top. So I'm going to put 360 first and then 50 next. So go ahead and add it. We're not using calculators. If you have a calculator, put it under your desk. No calculators till March. So we got 0. What's 6 plus 5? 11. Carry the 1. 3 plus 1. 4. So 410 degrees, that's the measure of the red angle. But it stopped at the same place as 50 degrees. Okay? But now, let's say I want to go the other direction. So what if I want to start here at the 0 and rotate the other direction and stop at the same place? All right, well then that means I'm subtracting 360. So this is where it gets a little icy. I'm going to put my negative 360 at the top, and then I'm adding to it 50. So you want to put the bigger number on top. Now you're going to go ahead and subtract. 0 minus 0 is 0. 6 minus 5 is 1. And then bring down the 3. But you have to remember that my answer is negative, right? Because I have a negative number being added to a positive number, but that negative number is bigger. So what I'm trying to tell you is that these three angles, 50 degrees, 410 degrees, and negative 310 degrees, all end at the same place. That's what I'm saying. That's why they're coterminal. Co means same. Okay, prefix co means same. If I say me and Miss Guyman are co-workers, it's because we work at the same place. Okay. All right, I'm going to ask y'all a question. Am I nervous to ask you this question? Yes. But I'm still going to ask you anyway. I want y'all to think about it, though. Don't just think about this for a second. Don't show me yet. I just want everybody to think about what quadrant 165 degrees is in. Not 3. This is 0. What's up here? 90. What's here? 180. And do we agree that 165 is in between 90 and 180? You just want me, you know what? I'm trying to work on my blood pressure. I'm not going to let you get me, Robbie. I rebuke the devil. Okay. So that is my 165-degree angle. Okay, what if though? What if I start at 0, I do one full lap, and then I stop there? That means I'm adding 360 to it. So what I want you to do is I want you to take 360 plus 165. All right, who got 525 degrees? All right, so I'm gonna go ahead and take this away. So now I'm gonna say I'm starting at 0, but now I'm rotating this direction. Well, that's a negative angle. So what we have is negative 360 plus 165. So we're gonna subtract like we would normally subtract. But you have to remember your answer is negative. So maybe I shouldn't put this plus sign because I don't want you to think we're adding. So let me take that away. You are subtracting. This is a regular subtraction problem. But my subtraction sign is up higher. It's up high. But it's still subtraction. All right, so we got 0 minus 5. We can't take 5 away from 0. So what do we have to do? Go to the 6. Borrow, the 6 changed to a 5. The 0 changes to a 10. What is 10 minus 5? 5. We can't take 6 away from 5, so we have to repeat. I have to go to the 3, borrow, and change the 5 to a 15. 15 minus 6 is 9. 2 minus 1 is 1, and this is negative. So these three angles, 525 degrees, negative 195 degrees, positive 165 degrees, they are all coterminal, meaning that they're different angle measures, but they all end at the same place. That's why we call them coterminals. All right, any questions? Does anybody need more time to copy down A or B before I erase it because I need some more space? Nope. All right, now let's talk about radians. Now, radians, we have to add and subtract 2 pi because 2 pi is equivalent to 360. So I need to add 2 pi. But we got a fraction. And I hope nobody is going to add that and say it is 10 pi over 6. If you are, don't tell me that. I don't even want to know. What do you need to have in order to add 2 fractions? Common denominator. So what do I have to multiply this fraction by? 5. So we're going to multiply this fraction top and bottom by 5, which is going to change it to 10 pi over 5. So I have 8 pi over 5 plus 10 pi over 5. That is the same thing as 2 pi. And then we're going to take 8 pi over 5 minus 10 pi over 5. All right, go ahead and find what you get. We got 8 plus 10. And if it's easier for you, you can also think of this as 10 minus 8. But know your answer is going to be negative. So go ahead and find those two. 8 plus 10. Eight minus 10. Okay. Yes, I'm going to ask you the question. Now, I also have low expectations, though. But who could tell me what quadrant 8 pi over 5 is? Who remembers from yesterday? What am I going to count by? What's the Miss Gillespie, Miss Bryant trick? What do I count by? What's half of my denominator? So we're going to count by 2.5. So if the numerator is between 0 and 2.5, that means it's in quadrant 1. If the numerator falls between 2.5 and 5, that means that it's in quadrant 2. If it falls between 5 and 7.5, we're in quadrant 3. And if it falls between 7.5 and 10, we're in quadrant 4. Show me with your fingers what quadrant are we in. We are in quadrant 4. These three angles are all in the same place. All right, let's do question D, and then we're going to start building our unit circle. Does anybody need more time to copy down C? All right, so let's look at D. I have to add 2 pi. What do I need to multiply it by to get a common denominator? 4. Go ahead and do that. So we have 5 pi plus 4 plus 8 pi plus 4. And then you're going to do the same thing, but you're going to subtract 5 pi over 4 plus, sorry, not plus, minus 8 pi over 4. I think I said it wrong. Let me repeat that. So first I'm going to add 5 pi over 4 plus 8 pi over 4. And then I'm going to subtract 5 pi over 4 minus 8 pi over 4. When you subtract, you're just finding the distance. So you can tell me the distance between 8 and 5. 8 minus 5 is 3. But because 8 is bigger, I'm going to have a negative 3. And 5 plus 8 is 13. So these are all coterminal. So we got 5 pi over 4, 13 pi over 4, negative 3 pi over 4. Because I'm a glutton for punishment, I'm going to ask this question. What quadrant are we in? What are you counting by? By 2s. I promise I cannot explain this any better. Like, I don't even know another way to explain this at this point. I really don't. I don't know another way, okay? Y'all trying to make me cry. Okay, I'm gonna ask the question. What quadrant are we in? Show me with your fingers. I need everybody to show me. Take a guess. We're in 3. That was better. All right, because you're counting by 2. So if its top was between 0 and 2, it would be 1. Between 2 and 4 would be 2. Between 4 and 6 is 3. Okay. So now we're going to start on the unit circle. So in your notebook, I do want you to title your note 6.2 Unit Circle Approach. We're starting 6.2. And I want you to glue down that cutout. Now we're going to work with the cutout more tomorrow, but I want you to glue it down. Homework 2 is out of the book. Now, who had Miss Kuznick last semester? All right, so I do homework very similar to how she does it, where we are going to grade it with a red pen. And as long as you have attempted, you have to show work. You have to show me work. I know that there is AI and photo math out there, so you have to show me. You have to show me your work. And you have to try the majority of the questions. So if it's 10 questions, but you only tried to do 6, I don't think that's the majority. All right, so as long as you are trying, because I don't want to penalize you for getting your homework wrong. Homework is practice. But you have to practice in order to do well in this class. You have to practice. Okay, so first of all, now we're going to switch to our blue paper, but I just wanted so you can put that notebook to the side. But what is the unit circle? To put it simply, and you don't have to write any of this down, you're just listening right now, pencils down. All a unit circle is a circle that has a radius of 1. Who remembers what radius is in geometry? What is radius? Distance from what to what? Center to the edge. So any circle that has a radius of 1 is a unit circle. Now, in geometry, you heard about these 3. Everyone heard about sine, cosine, and tangent. Remember that from geometry? Well, actually, there's more than 3. There are 6, okay? Sine and cosine, sorry, let me go back. Every single function has a sister. So these 2 are sisters. These are sisters. And these are sisters. They're sisters. Okay? Now, looking at the cutout that you just put down, I want you to tell me, what do you notice happens between the trig and the sister? So what you just glued down says that sine is equal to y and cosecant is 1 over y. What happened? What do you call these 2? Begins in math. What do we call them? Reciprocals. The sisters are the reciprocals, if you want to write that down. So to get cosecant, I have to flip sine. To get secant, I flip cosine. To get cotangent, I flip tangent. The sisters are reciprocals. That's how we're going to find the sisters. Okay? All right. So now let's hit our blue paper. Now we're not going to fill in everything. We're going to keep work. It takes a couple of days, but today we're going to focus on filling in the degrees and filling in the coordinates around the unit circle. So let's look at quadrant 1. And also, really quickly, the unit circle is based off of the 2 special right triangles from geometry. Who remembers 45, 45, 90, 30, 60, 90? You don't have to know how to find them, but just so you know, that's where the coordinates are coming from. All right. So we start off with 0 degrees. And then this is my 30 degree. This is 45 degrees. This is 60 degrees, and this is 90 degrees. Remember I said it's 30, 60, 90, and 45, 45, 90. Okay? And now I want you to pick a color, and we're going to highlight. Pick one color. I want you to highlight that. Pick another color. Highlight that. Well, actually, I'm going to use yellow. All right, we're going to highlight that. Go ahead and highlight those. And now we're going to fill it in. Maybe I should have had you write it in first and then fill it in. I don't know. Sorry. So what are the ordered pairs? All right. First of all, down here, because remember the radius is 1, that means that x is 1 and y is 0. At the top, x is 0 and y is 1. So you can go ahead and fill in those points. Now, if you can remember the numbers 1, 2, 3, you got it. So what I want you to do is I want you to count, starting with the x values, I want you to put a 3 and I want you to count backwards. And then for your y values, we're going to start with a 3 at the top and count down. And all of these are over 2. And then I'm going to go back and put a square root on top of every single number in the numerator. Why do you think I'm not putting a square root on top of the 1? What is the square root of 1? 1. So we don't put a square root on top of the 1. And there you go. That is the first quadrant of the unit circle right there. If you can memorize the first quadrant, if you can memorize that this is 3, you count back, then you come over, get a 3, you count down, you have the whole unit circle. All right, so now we're going to reflect that. So let's reflect it from quadrant 1 to quadrant 2. Oop, I went the wrong direction. Now, before we do that, let me go ahead and highlight. So whatever color you highlighted here, this is going to be the same color. Whatever color you highlighted there is we're gonna put the same color here. All right, and whatever color we put here, we're gonna put the same one here. Yes. No. It's like putting 1x. I wouldn't count it wrong. It looks weird, but it's okay. After you do that, I want you to write the exact same coordinate. So see how this says 1/2 root 3 over 2? I want you to write that right here. Write 1/2 root 3 over 2. That's going to go here. It's the exact same. And then you're going to write whatever coordinate you have right here. You're going to write this right in the middle. So I'm going to put that root 2 over 2. Root 2 over 2. And lastly, we have a root 3 over 2 and a 1/2. Now we're ready to fill in the degrees. Now you're basically adding to where you start. Now we're starting at 90. I'm going to add 30, 45, 60. So what is 90 plus 30? 120. So put 120 right here. That's my 120 degree angle. 90 plus 45. 135. Put that right here. 90 plus 60. 150. And we should know that here is my 180. Hopefully we know that. Okay. So now, this point is also going to be the same. So you can also reflect this 1, 0 over here. Okay, we're not going to worry about positive and negatives yet. I think we're going to do that tomorrow. Well, no, we could do it today. Okay. On the coordinate plane, all right, if this is my coordinate plane, over here, X and Y are both positive. What about over here? What's positive and what's negative? On this side, is X positive or negative? Negative. What about Y? Positive. So what I want you to do is I want you to put a negative sign in front of all of your X's. So put a negative in front of all of your X's. Negative, negative, negative. Because in quadrant 2, X is negative. So in quadrant 2, make all of the x values, because this is a coordinate pair. Every single last one of these represent x and y. So x is negative. Put a negative in front of the x. All right, so now let's go ahead and rotate down to quadrant 3. Still going to color code. All right, so if this is pink, then down here is pink, because that's the reflection. Because we're going to think of this as our mirror. All right, if this is yellow for me, then this is going to be yellow. And if this is blue, then this is blue. Then I want you to go ahead and write those same order pairs. I want you to write it again. So we have root 3 over 2, 1/2. Root 2 over 2, root 2 over 2. And then a 1/2 and a root 3 over 2. Did I? Oh, yeah, no, I did. Sorry. I was like, did I highlight wrong? No, that's right. All right. That's why I wanted you to color coordinate. Because you're just memorizing 3 things. And you're just reflecting that same point over and over and over again. So let's fill in our degrees. What is 180 plus 30? I heard somebody say it. 180 plus 30. I think Desire, you the only one know how to add, girl. Ain't nobody else learn. What middle school, what elementary you go to? Central over there teaching, I guess. They the only one teaching how to add. What's 180 plus 30? 210. Then 180 plus 45, 225. 180 plus 60, 240. And then down here is my 270. Okay, now we're in quadrant 3. So remember, quadrant 1, they're both positive. Quadrant 2, x becomes negative. What happens in quadrant 3? What did you say? Can you repeat that? What did you say? Negative, negative. They're both negative. So I want you to put a negative in front of both. Put a negative and a negative. Negative and a negative. Negative and a negative. They're both negative. And then down here, this would be 0, -1. Wait, did we fill in that -1, 0? Yeah, we did. Okay. So now we got quadrant 3 down. We only got one more quadrant to fill out. Quadrant 4. So again, I'm going to highlight. If this is pink for me, then this is going to be pink. And if this is yellow, this is yellow. And if this is blue, this is blue. And I want you to rewrite those coordinates over there. So I got my 1/2, root 3 over 2, root 2 over 2, root 2 over 2, root 3 over 2, 1 over 2. All right, we're in the last one. So quadrant 1, they're both positive. Quadrant 2, x is a negative. Quadrant 3, they're both negative. Okay, what about quadrant 4? What are my signs in quadrant 4? Positive, negative. So I want you to go in and put a minus sign in front of y only. Put a minus sign here. Put a minus sign here. Put a minus sign here. Only the y's are negative in quadrant 4. Now let's fill in my degrees. This is where that Addition. Elementary addition comes in. We got 270 plus 30. 300. 270 plus 45. 315. 270 plus 60. 330. And then we know that again at the top, this is my 360. So notice that I have two different values here. Okay. All right, we're going to end there for today. Tomorrow, we're going to talk about radians. But I want you, if you were to take a step back and look at your entire unit circle, you should notice that whatever color you have, that all 4 points should be the same. The only thing that's changing is what's positive and negative. Okay. If you could, please return color pencils if you borrowed them. Put your glue sticks back. And that's it. I appreciate it. Tomorrow we're going to finish we're going to continue in 6.2.